Hi guys, in this video I want to start talking to you about arithmetic series. And to do that, I'd like to talk to you about a very famous mathematician named Carl Friedrich Gauss. Now Gauss was a brilliant mathematician, and there's a story that's often told about him as a 10-year-old boy. And he was given a task by his teacher, in fact his entire class was given a task, to add up all the numbers from 1 to 100. And as the story goes, this was just to keep them busy for a while. But Gauss, he walks up to the teacher's table after barely, any time at all, and presents the answer. And the teacher doesn't believe that he could possibly have gotten the answer that quickly, until everyone else finishes the task, starts coming up, and it turns out that he was right all along. And the way that he solved it is actually through the use of arithmetic series, because of course the numbers from 1 to 100 form an arithmetic sequence with common difference 1. So here we see the series written out, adding the numbers 1, 2, 3 all the way up to 100. And what Gauss realized was that the difference between each term is constant, which is what makes it an arithmetic sequence, the numbers. But what would happen is if you added the first term and the last term, you would get 101. And if you added the second term and the second to last term, you would get the same sum. And if you added the third and the third to last, and the reason for this is that as the lower number gets larger, the higher number is getting smaller by the same amount. And so the sum of the two numbers remains constant. And so what Gauss did was to say, well, all you have to do is arrange them into pairs. And your sum of the first 100 numbers will just be 100 divided by 2, 50 pairs of 101, giving us a total of 5,050. Now once you've realized that pattern, it's very quick to actually work out the answer, as it was for Gauss as a 10-year-old boy. Of course, we can take this procedure even further and realize that it can be applied to any arithmetic series. So we take the sum of a general arithmetic sequence, term 1 through to term n, and this series has common difference d, so the second term is d larger than the first term, the third term is d larger than the second term, and of course if we work from the back, our n minus 1th term is d smaller, and our n minus 2 term is d smaller than that. So we can see that if we add our first and last term, and then we add our second and our second to last term, the total will remain unchanged. This then allows us to write a general formula for the sum of any arithmetic sequence. And that is that the sum of the first n terms will be given by half the number of terms, n over 2, times the first term plus the last, which can also be written as n over 2 term 1 plus term n. There is also another form that we can put this equation in, and that's by realizing that the last term is simply the first term plus n minus 1 lots of the difference. And substituting this in, we then get that the sum of the first n terms is n divided by 2 a plus d lots of n minus 1. Adding those two first terms together in the brackets, and we get that that can also be written as 2a plus d times n minus 1. Both of these formulae are equivalent to one another, and you can use either to work out the sum of the first n terms. If you know the first and the last term in the series, then you can use the first version, and if you know the first term and the common difference, then you can use the second version. In both versions of the formula, though, you must know the number of terms that you are adding together.